Enterprise Application Development, Architecture, Tech Stack, and Timeline Guide. Welcome back. Today's topic is Enterprise Application Development, Architecture, Tech Stack, and Timeline Guide. We'll cover what you actually need to know about enterprise application development. Now, let's talk about what is enterprise application development. Enterprise application development is the process of designing, building, and deploying software systems that manage core business operations across departments, user roles, and regulatory domains. These systems handle complex multi-step workflows, integrate with multiple data sources, enforce compliance rules at the data layer, and serve hundreds or thousands of concurrent users without degrading performance. The distinction matters because it changes the entire approach to architecture, testing, deployment, and governance. Enterprise applications share several traits that make their development fundamentally different from typical commercial software. Next up, architecture patterns every enterprise application needs. Architecture decisions made in the first sprint follow you for years. The two most common mistakes are choosing microservices too early, before domain boundaries are understood, and sticking with a monolith too long, until scaling problems force a painful decomposition under time pressure. Most enterprise applications benefit from a layered architecture in early stages: a presentation layer, an API/service layer, a business logic layer, and a data access layer. This pattern is predictable, easier to staff, and faster to deliver initial value. ASP.NET Core handles it cleanly, and ASP.NET Development Services teams can onboard without a steep distributed systems learning curve. Microservices make sense when specific bounded domains need independent scaling or deployment cycles. A payment processing service that deploys 3 times a day while the reporting module deploys monthly is a legitimate microservices candidate. Splitting a monolith into microservices for architectural fashion alone is one of the most expensive mistakes an enterprise team can make. Microsoft's .NET application architecture documentation provides detailed guidance on choosing between these patterns for real workloads. Next up, choosing the right .NET tech stack for enterprise applications. The .NET ecosystem has matured significantly over the past 3 years. .NET 9, released in November 2024, brings performance improvements that make it a compelling choice for greenfield enterprise applications. A qualified .NET development company will help you navigate these choices based on your workload, team composition, and integration requirements rather than defaulting to whatever is most familiar. ASP.NET Core is the foundation of most modern .NET enterprise backends. It is cross-platform, high-performance, and has strong support for dependency injection, middleware pipelines, and open API documentation. For REST APIs, gRPC services, and server-side rendering, ASP.NET Development Services built on ASP.NET Core handle high throughput with relatively low memory consumption compared to older .NET Framework equivalents. The correct deployment pattern for enterprise ASP.NET Core applications. Let's talk about how to modernize legacy applications without starting over. Most enterprise application work in 2025 and 2026 is modernization, not greenfield development. Organizations running .NET Framework 4.5 through 4.8 face a real problem. Those applications cannot run on Linux containers, cannot benefit from .NET 9 performance gains, and are increasingly difficult to hire .NET developers for. Legacy app modernization almost never requires a full rewrite. Our 5-phase .NET modernization roadmap covers the full process, but the core strategy comes down to 3 decisions. Legacy .NET Framework modernization uses the strangler fig pattern to incrementally replace components without a full rewrite. The pattern, originally described by Martin Fowler, works by routing new traffic to a .NET August 9 service while the existing .NET Framework system continues handling established requests. Over time, traffic shifts to the new system and the legacy application is deprecated piece by piece. The practical steps for strangler fig .NET application modernization. Moving on to .NET microservices, should you decompose your enterprise application? .NET microservices consulting engagements consistently surface the same pattern: organizations adopting microservices because the architecture sounds modern rather than because their scaling or deployment requirements actually justify the operational overhead. The conversation should start with a clear business requirement, not an architectural preference. A well-structured monolith is the correct starting architecture when the engineering team has fewer than 15 members, when domain boundaries are not yet fully understood, or when deployment frequency across modules is roughly equal. A modular monolith with separate assemblies and schema-isolated modules provides clean internal structure without the operational complexity of managing multiple independently deployed services. Many successful enterprise applications run as modular monoliths for years before decomposition becomes necessary. When decomposition becomes necessary, start with the bounded contexts that have the highest change rate or the clearest independent scaling requirements. In a healthcare application, the scheduling module may change weekly while the billing module changes monthly. Extract scheduling first. Use Azure Service Bus for async communication between extracted services and deploy to Azure Kubernetes Service for independent scaling per service. Avoid synchronous REST calls between microservices where possible. Those patterns recreate distributed monolith problems and eliminate most of the benefits of decomposition. Now, enterprise application development timelines, what to actually expect. Enterprise application development projects that miss timelines almost always do so for the same three reasons: scope that grows during development, integration surprises from under-documented third-party APIs, and compliance requirements discovered late in the project. Accurate timelines require honest assessment of what each phase actually involves before the first line of production code is written. Every serious enterprise project needs a defined scoping phase before production code is written. We run a structured 5-day blueprint sprint to define technical architecture, integration requirements, compliance constraints, and a work breakdown structure. Organizations that skip this phase spend the equivalent time resolving architectural disagreements during active development at far higher cost. A completed discovery phase produces 4 concrete deliverables: a data model, API contracts, an integration dependency map, and a risk register with mitigation plans. A typical mid-size enterprise application with 10 to 20 core modules and 5 to 8 external integrations takes 6 to 8 months of active development with a team of 4 to 8 engineers, assuming clear requirements and available stakeholders for weekly demos. Banking and healthcare applications typically add 2 to 4 months for compliance validation and security review. The final 6 to 8 weeks before go-live should focus on end-to-end integration testing, user acceptance testing with actual end users, performance testing under realistic concurrent load, and formal compliance validation. As a reference point, we rebuilt a logistics platform from 60% to 95% order visibility in 7 months with a 6-person team. Next up, how much does enterprise application development cost? Cost estimates without context are misleading. Here is what actually drives the numbers when working with a custom software development company on enterprise projects, based on projects delivered across healthcare, logistics, banking, and SaaS. The 3 biggest cost drivers in enterprise application development. A mid-size enterprise application with 10 to 15 modules, 5 integrations, and a 12-month build timeline typically costs $400,000 to $900,000. Applications with heavy real-time compliance requirements or complex legacy data migration can exceed $1.5 million. These ranges assume a competent delivery team. Underestimating by hiring the cheapest option usually results in a rewrite within 3 years. Let's talk about moving on to conclusion. Enterprise application development done well is not fast, and it is not cheap. But running a business on aging .NET framework applications that cannot scale, or on a patchwork of SaaS tools that do not integrate, carries its own compound cost in productivity loss, compliance exposure, and competitive disadvantage. The architecture patterns, .NET technology choices, and modernization strategies in this guide are a starting framework. What matters beyond any specific technology decision is the discipline of the process, thorough discovery work before coding starts, honest scope management throughout delivery, and human checkpoints where engineers and stakeholders review real progress against real requirements. Q Services specializes in .NET modernization with human-in-the-loop governance for enterprise applications, with over 500 delivered projects across healthcare, logistics, banking, and SaaS. If you are evaluating a .NET development partner for your next enterprise build or modernization project, ask one question before signing: how do they handle scope changes when requirements shift 2 months into development? The answer tells you everything about how the project will actually go.